Hello beautiful people, welcome back. So in this competitive programming series we'll take a next question of a recursion method, and the question name is combination sum, and it is very interesting and a medium level question which will come in your placement drive, and I will teach you each part of this question. So without wasting any time, let's get into it. And if you haven't subscribed my channel, subscribe it now, share with your friends. Okay, so let's get into it. The question says that a given of array of distinct integer and the target integer, return the list of all unique combinations of candidate where the chosen number of sum of the target. You may return the combination of in any order. Okay, so not reading this statements, let's understand by using examples. Okay, so first example is given, the candidate enters that is 2 3 6 7. Okay, and the target value as input has 7. So we have to find those combination which have the sum of 7, that is the equals to the sum of the target value. And you can see the elements within the array are given as 2 3 6 7, and the sum of and the elements which make the sum of the equals to the target value, which are they are 2 3 and 6 and 7. Okay, so we have to find those combinations among the elements of the array which is equals to the sum of the target value. Okay, and you can see as a second example 2 3 5 and target value is 8. So we have find the combination of 2 2 2 2 2 3 3 3 and 5. Okay, so this is the question and this is the basic plot of the question. Let's try to understand what is behind this question and what algorithm and what method we have to use for this question for better and better time complexity. Okay, so I have taken this example. As you see, this first test case, I have taken this only for making you understand. Okay, so let's fit this screen. Now we have given the target value, that is 7. Okay, now the first question arises how we have to approach this question. Whenever there is a question of combination and whenever there is a question of we have to pick an element, or we have to make a combinations among the element, or we have to find the subsets among all the elements which is equal to the sum of the given value, we generally use the method recursion. Okay, recursion is a method that calls the function again and again and run it and return some value. So here there is a method, or way you can say there is an algorithm which generally uses in the combination, that is pick or not pick. Okay, if you pick an element, if you're not picking element, there are two options basically, right? So let me show you. We have given an index of 0 1 2 and 3. Okay, by I'm taking this example. So the pick and non-pick says that, let me show you, if you pick the element this, okay, the element at 0th index, okay, that it is given 2. Okay, if you pick the element at 0 index, or if you're not picking the element of 0 index, then what will do? If you pick the element of 0 index, let's say 2, then you will not, then you have two chances again, if you're picking the element 2 again, or you are not picking the element 2 again. Okay, we have not given in this question, we have not given any restriction that you can choose the element at once only. Okay, if there is a option that you can only choose an element at once, we have two options. We have picked the element and we have to move forward. But in this question, we can pick as many as time as you want to pick that element. Okay, so now if we have two options, okay, and the recursion is working only and only on method. Method means function. So let's say we denote a function j, okay, having some parameters, right? So we have taken a parameter of, let's start with index 0. Okay, and we have taken another parameter, that is index, that is the target value. We have given target value 7, and the element we have chosen from the array, we have to store that elements in some data structure, right? Data structure can be an array, then array, a stack, a list, and a queue, anything you want and anything you are ease and uncomfortable. Okay, so I am taking a data structure, let's say stack. Okay, and initially it is empty. Okay, now I have told you that we have two options. Okay, first option is we have to pick an array, and another option we don't pick that element. Okay, sorry, not array, we have to pick an element, we are not picking element. Okay, let's say we have to pick an element at 0 index. Okay, we are picking an element at 0 index. So when we picking element at 0 index, which is 2, okay, so there are two options again. If you are picking element or you are not picking element. If you are not picking element, you have to move forward. Okay, if I pick the element, the index will remain 0. Okay, if I pick an element 2, okay, and we have to achieve the target of sum of 7. Okay, so if we pick the number element 2, then what will remain in the target? 7 minus 2 is 5. Okay, and we put that 2 element in the data structure. And what if we are not picking this element? What if we are not picking this element? We will move forward to next index. Okay, so index will be incremented. The target is still 7 because we haven't choose an element, so no effect to the target, and data structure is still empty, and this is still a function, right? So I am able to understand you what is happening or not. Okay, so let me scroll down to you. Okay, wait. Okay, yeah, so I think it is sufficient. Okay, now another two option is coming, that is picking or not picking. So if I pick element at 0 index only, so what will be the chances? Let's see. The index will remain same because we are picking the same element at 0 index. Now we have the sum 5, we have picked 2, so what will remain? 5 minus 2, it is 3. And data structure, then we fill the data structure from element, we have taken 2 and another 2. Okay, as you see, the 0th index have element 2. And what if we are not picking the element? Same, the index will increment, the sum will remain 5, and the data structure have only element 2 at this case. Okay, at this case, and we got this error. Okay, now again we have two options, pick or not pick. If we pick element 2, and if we're not picking element 2. Okay, so if we pick the element 2, what will happen? 0, 1, 3 minus 2 is 1, and the data structure is filled with another 2. Okay, 2, 2. Pardon my writing because I am using mouse, that's why it's a little uncomfortable, but I make you understand very sharply. Okay, and if you're not picking an element, still the sum will be 3, and the data structure having the 2 and 2. Okay, now the turning point came that we have to go by this only. Wait, now the picking method will not applicable over here because the element in the array, that is 2, is greater than the target value. Okay, so if you minus the target value, then the given element, it will give a negative answer, so it is not applicable here. Okay, the index value is greater than, sorry, the target value is greater than the index value, so here the picking method is not applicable. So what we gonna do? We do the not picking method. So in this, what will happen? So we know we'll go for next index. Okay, the sum will remain 1, and the data structure will be 2, 2 and 2. Okay, now we see at index 1. What is index 1? We have element 3, here you can see. Okay, so we do the checking. We have to pick the next index 1 or we have to not pick the next index 1. Okay, so as you see, 3 is greater than 1, so again this condition applies. This condition applies that the target value is greater than index value. We again choose not pick because it is not applicable also here. So what we're gonna do? We simply increase the index. We're gonna say 1, and still the data structure is filled with 3 2s because we don't picking the element, we are not able to picking the element because it not satisfy the condition. Again we check if we want to pick or we have to not pick. We see at index 2 Okay, we have 6. 6 is greater than again 1, so we are not able to satisfy this condition. We will not pick this, will not pick this. We go to not pick option and we will increment the index, and again the data structure is filled with 2, 2 and 2. Now what next? Okay, again we have two options, pick or not pick. As you see in third index, the number is 7. Okay, so we'll not able to pick this element, so again we go for not picking this element and we'll go for here j. Okay, and fourth index 1, and the same data structure is there 2, 2, 2, because we are not picking this. Now at fourth we have completed, we have traversed all these elements in the array. Now what? We got this data structure. Wait, let me change the color. We got this data structure. Okay, so in this data structure we got 2, 2 and 2, and what is our target value? It is 7. So thus this sum is equals to the 7. This sum is equals to 6, and 6 is not equals to t. So this combination is not correct combination, and we have to traverse more. Okay, we have to see more. So what we're gonna do, we go back. Okay, so what we have learned in this, that we have to stop when index is equals to n. As you see here, index equals to n, and the target is greater than equals to I element. Okay, so these are the two termination, or you can say the backtracking conditions which are applied on this question. So next step, we haven't find the combination yet, so what we will do, we go backtracking. Okay, we go from here to here, then again here, then again here, we go again here. Okay, then we go again here where we choose 2. For this I suggest you that we have pick a 2 here. Okay, so for getting this data structure again, we have to remove 2, because for getting this data structure we have to remove 2 also. Okay, so when we remove 2, we find this data structure. Okay, we found this data structure. Now we applied this and we applied here. So we have checked this option by picking 2. Now we'll go for this option. Okay, not picking 2, and I am erasing this stuff. If you want to take a screenshot, take a screenshot for 2 seconds. I am waiting. Okay, so I am removing this stuff. Okay, because it's creating a mess little. Okay, so we have picked this. Okay, so now we are going for not picking the, wait, we are going for not picking the 3. Okay, not picking the index, not picking the element 2. Okay, now wait a minute. Okay, so let me erase this. Okay, so if we are not picking the element at index 0, then what will go, we go for next index, right? We go for next index, that is 1, the sum is 3, and the data structure is having 2 and 2. So we'll check again we have to pick it or not. Okay, so as you see at index 1 we have to pick it or not, and index 1 we have 3. So if we pick 3, okay, if we pick 3, j is equals to 1, the sum is 0 because 3 minus 3 is 0, and the data structure is filled with the element 2, 2 and 3. Okay, and if you are not picking this, similarly what will happen, index will increment. Okay, and the index will get 2, the sum will be 3, and the data structure is filled with 2 and 2. Okay, so what is the termination point, what is the end point of that? If the target value, wait, I highlight with the greens another color. If the target value is equals to 0, if target value, if the target value is equals to 0, then we have to check the data structure 2, 2 and 3. So as you can see, it's equals to 7 and equals to target value. Thus we found one combination among them. Okay, so by doing this we can traverse all types of combination in the given array, and it is one of the easy and most convenient method of getting this type of combinations and the sum of that combination. And if you find this type of combination, you can do all the operations which are asked for the question. Okay, so here we find this type of combination. Okay, so if you traverse all this type of not picking and picking and all type of combinations of elements given in the array, you will find all the combinations like this. We found one, and if you traverse all this combinations and all this possibility, you will find another all the combinations of the target value. Okay, now let's see how we have to proceed in this question. So this is the scenario of the what we're gonna do in this. Okay, so let me show you here. So we have to take a recursion function, we have to make a method. Okay, we have take a method of parameter index, target value and data structure we have gonna take. I say you that we have two options, picking or not picking an element. If you are picking the element, the index will remain same, the target value will minus that element of that index, and data structure we have to find doing the operation of add. Okay, and when we going to and until and unless we are not satisfying this condition that the target value is greater than ai and index is equals to n, that means that we are all traverse this array and we are not finding the value which is greater than the target value, then we have to use backtracking. Okay, then we will return and we will go backtracking. And what is the sign of getting the correct combination? The sign of getting correct combination is t is equals to 0, and if the target value is 0, that data structure elements will be considered as the best combination of the targeted value. And else if you don't find this and anything else find, target value is remain 1. As you can see here the target as you can see here target value is not getting 0, so we go backtracking and return 1. Okay, so here also same thing, we go return. And not picking scenario, if we are not picking that index, we have to increment the index, the target will remain same and the data structure will remain same. So this is the basic scenario of what we have to do and what we have to not do in this question. So let's jump into the coding. First of all, let me make a result which we have to give the has an output. Okay, so let me define a function track, and the candidate is a list of that the input numbers. So when we have discussed that we have to initialize as index, so I will initialize as candidate. Okay, and what we do next, we have to take another, you can say target value, so target. Okay, and a data structure. First of all, we see the termination condition. So if target equals to 0, okay, if target equals to 0, then what we have to return no we have to return the data structure. So copy and return. Okay, so we have to do this, and we append ds dot copy. Okay, we have to return the data structure and append that data structure. Okay, and else if target is greater than 0, sorry, is less than 0, negative value, or it's something like I have told you target value is greater than that incremented I index value, so it will stop that working. So wait return. Okay, so this is the condition. Now we have to take two conditions, pick or not pick. For that we have to iterate in reverse reverse where candidates. Okay, so we have to do, first of all, if backtracking is happening, we have to append I, we have to append in data structure, right? And what happens if track, we have to again. So now if we are picking or not picking option we have completed, and for track what we have to do, we have to I target minus candidate wait I. Okay, so by instead of traversing like I, we traverse the whole in single. This is slicing, and I am traversing from 0 to all the candidate keys. Okay, and ds. Okay, data structure will be same. And if the backtracking happens, the ds dot pop will be done. Okay, and then that's it. We have to just call this function track. What are the parameters? Candidates, target, and the data structure we have taken, which is a list. Okay, so this is all the we have to return res result. Okay, so let's try to run this code. So okay, the problem is it gives the duplication, or it is taking a same combination in some reversing index. Okay, so okay, we can do one thing. We can pop the elements which are used in the combination, so it not iterate its value in another index form, right? You can see here 3 2 2, again 2 3 3, and 2 2 3. So we don't want that. So what we do, we pop that value out. Okay, so let's try this. Hit or not. Yeah, it's working. And when we submit this code, let's see it's testing all the test cases or not. So yes, it's working. And I'm sure you like this question. If you have any doubt, I will provide you code, or I think you should try it by yourself. If you haven't subscribed my channel, subscribe it now, and share with your friends. And if you like this, hit a like button, man, it supports me a lot. So let's see in next video. Okay, bye bye.